Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ukobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 9 still on a differential calculus. Then it says determine f prime x from first principle. Determine f prime x from first principles if it is given that f of x is equals to 2x squared minus 3x. So, okay, with our trick now, we have our f prime x is equals to 2 times 2. We know that we take this one, jump down to multiply that. That's 4x. And then this one, if we have a variable with only a coefficient of 1, then the derivative is the cofunction, right? Then now that we know that we know the answer that we should expect, right? So that's not what will get you the 5 marks. So this is f of x is equals to 2x squared minus 3x. And then below you want to have the expression for fx plus h. Now again, remember I said this means where you see x, you have to substitute with that x plus h. So this is 2x plus h, and then you have square minus 3, and then x plus h. Now at this point, this will expand, and then it will give you x squared plus 2xh plus h squared. Then if you continue with that one, that's negative 3x minus 3h. So at this point, you can multiply inside with this 2. So that's 2x squared plus 4xh plus 2h squared minus 3x minus 3h. Yeah, so you have to be really in a good mood to do all of this stuff here. Otherwise, you're going to make a lot of mistakes. Then f prime x is equals to lim h approaching 0. And then we have fx plus h minus f of x over h, right? Now, you want to take all of that expression there, and then 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus the whole expression. So note, when I'm about to subtract an expression, I need to put it inside the brackets, right? So that I do not make any mistakes, and that I make sure that that negative here also affects this second term of this expression there. So minus 3x, right? Then all that over h. Now at this point, you want to cancel out the ones that will cancel out. So that's 2x squared, cancel off the 2x squared. The negative 3x will eventually cancel off that negative 3x because it will come out as a positive. And then there you go. You have a lim h approaching 0. So note that you always have to write that one for as long as you still have that h over there. You need to always carry that lim h approaching 0. Then over h. Now at this point, we know what should be done. We take the h out because it's a common factor. Then we have 4x plus 2h minus 3, and then all that over h. Now at this point, what do? Divide the h there, divide the h there. Then we say lim h approaching 0. So this will give us 4x. Okay, so now at this point, we can just get rid of the lim h approaching 0 and then just replace by 0 there. So we have 4x plus 2. And then where there's h, we put 0, then minus 3. So therefore, our f prime x is supposed to be 4x minus 3. And then again, we are confident with our solution because we have already got it there, right? So it's just a matter of having to confirm whether we did everything correct. So had we made any mistakes there and then we saw that it was not the same as this one here, then it could have been easier for us to go back and check where we missed a calculation there. So it's very, very important that you start by first checking what the answer should be, so to avoid mistakes, right? Then let's move to 9.2.1. It says determine dy dx if y is equals to 4x to the exponent of 5 minus 6x to the exponent of 4 plus 3x. So we have 9.2.1. And as my maths teacher used to say dy dx, and then you take 5, jump down to multiply the coefficient. So that becomes 20. And then from that 5, you subtract 1. So that's 4. Then take 4, jump down to multiply the negative 6. And then now we know that that one should give us negative 24. Then if we subtract 1 here, that's 3. Now, if the coefficient has a variable of 1, then our derivative is the coefficient. So if the variable here has an exponent of 1 meant to say, then the answer is the coefficient. Then 3, right? So there we go. They mark, that's 3 marks. So that means for every derivative expression there, it's a mark, right? Then 9.2.2, again, you will remember the rule. We said do not derive whilst the variable is in sat form. So we cannot derive with the variable in sat form. But also another thing, we cannot derive, do not derive whilst variable is a denominator. So 2 important rules that you have to note. Do not derive whilst the variable is in sat form. Do not derive whilst variable is a denominator. So that means the first thing that we have to do there is prepare our expression for derivation. Now this one is easier to prepare. We just go negative x to the exponent of 1 over 3. Remember, we take its own exponent over the exponent of the root, and then over 2, right? Then here, this one is going to be, remember it's square, so it needs to be 1 over, so let me just take it out from the bracket. So it needs to be 1 over 9x squared. Remember the square here, according to the law of exponents, if we have an exponent like this, this is similar to a to the exponent of n and b to the exponent of n. So this exponent here applies to the numerator and also to the denominator. So hence you see there is a 9 here and 9x squared. So, but then again, we haven't fulfilled the second rule here. Do not derive whilst variable is a denominator. So we still need to keep our dx. And then what we can do here so that we can clearly see our coefficient is just to write this as negative 1 over 2 and then x to the exponent of 1 over 3. So I did not change anything. I simply wrote it in a way that I can easily see. Then from here on, I have the 1 over 9. Which happens to be my coefficient at this point. But then remember, in order to take this one from the denominator to the numerator, this is how I do it. And then it has a negative exponent right now. Because we know, according to the law of exponents, if I have a 1 over a to the exponent of m, then this can be written as a to the exponent of negative m, right? So there's still a lot of exponential rules in play here. Then at this point, we can see that our expression is now ready for derivation, right? So now let's cook. Then the exponent jumps down to multiply the coefficient. So that's 1 over 3 multiplied by negative 1 over 2. So it will be negative 1 over 6. Then if we subtract 1 from here, then this will give us negative 2 over 3. And then from here on, we say negative 2 multiplied by this. This should give us negative 2 over 9. And then if we subtract 1 from here, that's x to the exponent of negative 3. And then just like that, we have our derivative. Yes, so we have cooked. Then, okay, so that's it, guys. For 12 marks, that's how you were supposed to go about answering that question. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.